All right, so the geometric series, when we turn to infinite series now, adding up the infinite terms, will actually just be the limit of the partial sums. All right, and this is just following the same idea that we talked about before. Right, for an infinite series, right, we look at the sequence of partial sums. If that sequence converges, the infinite series will converge. Right, that's what we had, that the infinite series is just the limit of the partial sums. Okay, so just taking that same idea and we're now applying it to our geometric series. So that means that the sum, as k goes from 0 to infinity, the infinite series of a r to the k will be the limit as n goes to infinity of the partial sums. What are the partial sums? That's the sum as k goes from 0 to n minus 1 of a r to the k. Okay, that's my partial sum. But we can express partial sums in terms of n. So that's the limit as n goes to infinity of a times 1 minus r to the n divided by 1 minus r. So how do we evaluate this last thing? How do we evaluate this last thing? Well, from earlier, from the last section, we know a little bit about what happens to r to the n, right? Because we looked already at the geometric sequence, right? And we kind of discussed what was going on with that r to the n. Right? And basically there are 4 cases. If the absolute value of r is less than 1, it's going to converge to 0. If the absolute value is greater than 1, it's going to diverge. If r is equal to 1, right, well, a is 1 in this case now because we're just looking at r to the n, right, then that's going to go to 1. And if r equals negative 1, it's going to alternate, so it's going to diverge. So taking that information and summarizing, we can say the following, that the limit as n goes to infinity of r to the n is equal to 0 if the absolute value of r is less than 1. It's equal to 1 if r is equal to 1. And then the limit does not exist if r equals negative 1 or absolute value of r is greater than 1. Right? It doesn't exist. So those are the situations there. So if r is greater than 1 or r happens to be negative 1, then this whole thing is going to not converge. If r equals 1, then this would actually be 1 minus 1 over 1 minus 1 would be a 0 over 0 limit. And as I'll explain in a couple of moments, that's actually going to go to 0. That's going to go to infinity in this particular example. That's actually going to go to infinity in this particular example. So why is that? Because if r is equal to 1, then a r to the k would just be the sum of the a's as you go to infinity. So of course that would go to infinity, right, the infinite series. So if r equals 1, again that would be 1 minus 1 over 1 minus 1, would be a 0 over 0 limit. It's indeterminate, but when we think about what it is, if r is 1, this would just be adding a up an infinite amount of times. And if you take a non-zero number and add it up an infinite amount of times, it's going to be infinity. It's going to be infinity. So 1 is also, as far as the infinite series is concerned, it's going to diverge. But if the absolute value of r is less than 0, then r to the n is going to go to 0. R to the n is going to go to 0. And therefore, in that situation, if r, so if the absolute value of r is less than 1, then that infinite series, k equals 0 to infinity of a r to the k, will actually converge to a over 1 minus r. Will actually converge to a over 1 minus r, because r to the n becomes 0. So the numerator is just 1. 1 times a is just a. And the denominator is just 1 minus r. So for infinite series, when it converges, it's actually a lot easier to compute what it converges to than it is to compute the partial sum at some point. It's actually much easier to do. And so again, just to kind of recap, following what we've discussed, the limit of the geometric series is the limit of this expression. But this expression only has a limit if the absolute value of r is less than 1. Okay, obviously those two scenarios there, it doesn't exist. And as we discussed, if it's 1, then that limit would actually be a 0 over 0 limit. That would actually be a 0 over 0 limit. And if you go back to where it came from, that would actually be the sum, r equals 1. This would be the sum of a as k goes from 0 to infinity. If you add any non-zero number up an infinite amount of times, you're going to get infinity. So the 1 is also going to diverge as well. So in those three, it's going to diverge. In this one scenario, it will converge. Okay, it will converge, and it will converge to a over 1 minus r.